We will now go to the last speaker of this session, and what he's going to highlight is the need for community annotation of molecular information. I think one of the aspects of metabolomics of mass spectrometry period is that one person, one lab can no longer annotate all the information that's becoming available. And so how do we come up with a solution for that? And Maner Ashkenazi from NIST will speak to that particular problem.
Right. So actually, I need to address immediately what you just said, because though I will be speaking about Lifeline-SOS, which is a software extension to the NIST MS software, and a lot of what I'm going to be talking about is NIST libraries and NIST software, I am, in fact, not a NIST employee. I represent biomedical hosting, which is implementing this. And it's normally this wouldn't matter so much, but impersonating a federal agent is actually a crime. So I don't want to be that guy that got arrested at ASMS. So I am not from NIST. I'm a huge fan, but I'm not from NIST. So as a matter of fact, this talk is so NIST-centric that I wanted to take the opportunity to give you a little bit of a history, because most of us interact with the NIST Spectral Library. I think we had a few instances today where we sensed the primacy of the empirical, of the sample that was run, a standard that was run, the spectra that was curated manually. And these libraries are enormous for something that's manually curated. And this doesn't come in an instant. This project has been ongoing. The first release was in '92. And are you hearing me okay? I'm getting an echo, okay. This is ongoing since '92, and the mandate to generate these reference spectra actually comes from an act of Congress from 1968 called the Standard Reference Data Act, which extended the mission of NIST to reference data and not just reference materials. This is why we get these spectra, and it's just important to realize that this has a history and it wasn't built in a day. As a matter of fact, NIST itself can be traced to the Constitution, where it was said that we need to fix the standards of weights and measures. And if you really think about it, the call or the aspiration for true measures goes back much further. This, by the way, is the accurate mass standard of the time. So that, we've come a long way. But I don't want to digress too much into the distant past. So let's just zoom forward to, you've heard about NIST 14, and so we're going to talk about a little extension to the NIST MS software that is not, even if you download NIST MS 14 and you run it, you won't be able to see the feature that I'm about to show you. It's there, but you need to contact us to have it, and it's a sort of a pre-alpha. I'm actually, in a sense, trying to elicit alpha users for this. This is the point of this talk, is to show you that it's in the system, but to help us get the interfaces right, etc. I'm eliciting volunteers. We'll shift the status of the project probably at least once at IMSC in Geneva this year. So just to get it out of the way in a sentence, what this new feature is the ability to instantly tell NIST that you're disappointed that a spectrum wasn't ID'd and what the spectrum was, directly from NIST MS through the web. So it's a web-based extension. And it bears looking into why NIST would open up to such a direct form of feedback. After all, on some level, they're meticulously working on reproducible signal, identified signal, making spectral libraries for the ages. Why they would want you to be able to submit, bomb them, overwhelm them with spectra that were not in the library I'm about to explain, in fact. So the first step in curation is to separate the irreproducible from the reproducible. And as I've just said, the result of the process that you normally see is a reproducible and identified signal. But in fact, NIST has started to curate systematically this other category of data, which is reproducible but unidentified. And it's a useful class of data, and it's worth doing. In fact, there was poster, I think 48 on Monday, was the first evidence of this process. It involved a large data set of pediatric urine samples. And when you see spectra in this talk, they're all from that. We use that to cut the teeth of the system. So this is GCMS, nominal mass. All of the data that we'll show when you see it flying by is from that category. But what we're looking in these data sets is we're looking for reproducible signal that's not identified. So this is ongoing. And to that extent, if you have spectra that you haven't ID'd, not necessarily from just the whole universe of sample types that NIST is curating, when you submit spectra, it allows NIST to elevate some spectra from noise to signal because it is reproducible. So that's the interest of NIST. And now to show you what your interest as an end user is, I need to walk through what it looks like from the user's perspective. So this is the NIST MS software in the standard layout. I suppose most of you have already used it. So, but just if you haven't, this is your query spectrum. This is the best hit. This is a visual representation of the evidence that this is the best hit. And most importantly, this is the histogram of the match factors, and you can see that the best hit is clearly separated from the second and onward best hits. And so you feel very confident, and you essentially copy the structure from the reference to your spectrum, and you feel confident about that. When this happens, you're not able to get an ID. Up till now, well, you just noted that to yourself. You may maybe have your own library of unknowns. What you can do now is you can right-click in the top area, again, if you've enabled this feature, and then you can submit it to this extension that I'm talking about called Lifeline-SOS. So you're asking NIST, and I'll show you in a second the rest of the community, have you seen this before? What do you think this is, and what's your metadata about it? And so what ends up happening at that point is, first of all, the software warns you. You realize that there's a spectrum leaving your institution, going over the web to an external site. I know this eliminates some of us from being able to use this, but for the rest of you, you'd click OK, and you'd maybe say, don't warn me again, because that's annoying. And then you get to a page where the system will give an accession to your submission. And the first thing that you see is, as a matter of fact, I just want to point out, you can do this anonymously. So at this point, I haven't yet said who I am, and I don't need to, and it's already a useful contribution to the community. The first thing that you see here is a big empty table, and that's just confirmation that there are indeed no NIST IDs with a match factor greater than 500. If, for example, you have the last version of the database, this will allow you to just confirm that it's not an issue of database version or some other. You just want to make sure that you're seeing the same thing as an instance running with standard parameters on the server. This is what you would see if you submitted something that has an ID. In order to give metadata, and obviously we would like metadata, you need to log in. When you log in, you can, and there's a process for registration. When you log in, you can claim the submission. That means that submission is then attached to your account. And once you do that, there's a little provenance panel. And this is a form, and I know that forms are painful, so we're working through different options for storing what you loaded previously or storing collections of previously defined samples. It is possible to overdo this, so part of what we're asking alpha users to do is give us a sense of what's the sweet spot in terms of just giving a certain amount of information but not giving a headache to the submitter. But that's basically the metadata that we're not trying to make this too complicated. You can, if you scroll down, you can look at the spectrum that you've submitted in the same way. Now, this is on the web page in the same way as you were looking in your own tool, just to confirm that you've submitted the same thing. If you're adventurous, you can provide a structure to a fragment. I'm really only showing this to show that the system supports a discussion down to the level of a structure, but most people will want to annotate this just at the level of a molecular formula. You can annotate this with a guess about the molecular ion, and that becomes a virtual peak that's also annotatable. So if you have a theory about what it is, if you click on it, you can annotate it in the same way. So basically, there's a little bit of there's a way for you to scribble on top of your submission, not on top of other people's submissions. So another piece of information that you're being provided is a run of a tool called Aristo, which tries to give you a little bit of information about the spectrum. We're all very leery of automated techniques, especially, I mean, we're talking here about a system that needs to support nominal mass spectra that could be coming from any kind of sample. We can't make any assumptions at all. So what this tool doesn't do is attempt to get at a structure. It's just attempting to give you an ontology referenced from a well-defined ontology. If you click on the particular ontological comment that was being generated, you can see a representation of what the system saw when it looked at your spectrum. So what you're seeing here is a circle for every ontological category in the Chebi database. This is the example of that I clicked on. So you basically have a tree of, it's more than a tree, it's a directed acyclic graph, but you have a well-curated hierarchical ontology, and what this tool attempts to do, and this is an impossible attempt, is to go directly from a spectra to a broad category. So there are ways to do this, and really this is a placeholder. So this is the reference for it. But another thing that we're soliciting is if you have tools that are relatively robust, the more the merrier. So we'll have slots for additional tools, and we're soliciting submissions. We're not taking such batches of spectra that we won't be able to run anything that you provide code for. So at that point, I want to go back to maybe the most important aspect of this, which is when you're submitting the spectrum, I think the thing that you want to know the most is, has anybody else already seen this? And so at the top of the reference page, you will see that the spectrum is assigned to a group, and every spectrum will be assigned to a group. And if you're the first to see it, you will be the founding member of that group. And you will know that because the accession of your spectrum will be the accession of the group. And so just by looking at this, I know that this group already has somebody else because I'm not the first submitter. So that's exciting, and I want to click there and see what other people have seen. But before I do that, I want to show you a way to see your spectra. Over time, you'll build up a set of spectra in the context of all of the other submissions on the system. So if you click on the Lifeline button at the top, you'll go to your sort of home page, and it looks like this. Every one of your spectra is in light blue, and you can see that many of the submissions will be these orphan spectral clusters of one. But every once in a while, you'll have spectra that land into a cluster that has many members. Once you allow bulk submission, this is what happens. So this is we have a bulk submission user called Nesturin, and it has been busier than me. Yeah, not he. It's been busier than me, but so that's what that would look like. But basically, and just in a word, the way this clustering is done, it's a very simple greedy algorithm. The spectra comes in, you look at the existing centroids, the existing average spectrum of every of the groups. If there's what's clearly a match, you join and you update the average spectrum. Otherwise, you end up being a founding member. It's that simple. And there will need to be multiple passes because we know that this can, on occasion, cause aggregation of spectra as the centroid moves between more than one. I mean, these are well known, but you need an algorithm that moves quickly because you want to give somebody immediate feedback. So this will be a combination of online and offline analysis. So your spectra may be reassigned. But at any rate, in this view or in the previous view, when you click on a cluster node, you can see who, well, not who, but whose spectra, what spectra, what accessions make up the group. And you can see also what is the best match factor for any one of the members. So you can see that even the member with the best match factor got a pretty weak one. So this is a legitimately new cluster. Or at least it looks like it. The other thing you can do is you can look at the consensus, and by hovering over the entries of the other contributors, you can see what their contributions are overlaid on top of the consensus, and you can zoom in and see possibly features that are only apparent when you average, and therefore you might consider that maybe you overreached when you assigned the molecular ion, for example. So let's say I got cold feet and I decided I somewhat regret my annotation. I want to share that with the rest of the members of this group. So by virtue of landing on this page, I have inherently the right to post comments on it. And we're essentially trying to get a discussion going to augment the annotation of these unknowns by the members themselves. And in a way, this is probably the most important feature that we're trying to get at with this tool, because when you cluster spectra, you are indirectly clustering their owners. And by giving them a platform to discuss these overlaps, we're basically making it possible to answer another age-old call, like the age-old call for true and just standards, which is to come and reason together about these spectra. So if you would like to participate in this reasoning together, if you send me an email, we can enable this very early alpha version of Lifeline-SOS on your NIST-MS copy. If you want to, sort of in network speak, just lurk, this is the website of the project, and there is a blog associated with it. The first thing I'm going to put on there is this slide set. I'd like to thank Steve Stein from NIST, who is the prime mover of this entire effort. I'd like to thank Yuri Mirochin for adding the linkage into NIST-MS that throws out the spectrum, and Gary Mallard for providing the data set which we use to prime the process. He's the sort of chief curator of the unidentified right now on some level, and so this was the data set that we were able to start with. I'll take questions if you have any.
Thank you. Thank you, Manur, for a wonderful and exciting way of looking at data. I will steal the first question. How are you going to feed back the information if these clusters become annotated? You know, not everybody's going to be 24/7 logged into NIST.
Yeah.
And so how are you going to feed that back to them?
So this is part of the process. We want to make sure that we don't. It would be so when you register, you give your email. So it's a triviality to make it that you get an update when somebody annotates this, but we have to be very careful because we don't want to become spam, and this could easily turn into that. So we want to tread very carefully. Now, obviously, in the long run, the feedback is through the library. But I understand what you're saying, and this is something that we're experimenting with. I had originally just stated flatly that you'll get an email back, but I walked back that
But maybe you can just periodically, every 3 months or so, have an update, so that you don't get continuous spam. It's just
Yes.
every once in a while you get an update.
Yeah, we're definitely, this is exactly the kind of feedback that we're eliciting. I mean, we're
Yeah, we all get saturated with emails. So.
exactly.
Anyway, there's a question right there.
Is this going to be limited to EI spectrum, or are you going to do MSMS too?
So right now, everything I'm showing is GCIMS. It will go where the libraries go. So since the libraries have it, it won't be. But right now, the tool supports GCIMS.
So we're actually also developing for MSMS data with Nuno Bandera at UCSD. We actually have an operational version for all types of data, and you can actually upload your entire project data as well. So it's sort of the equivalent.
Yes.
So that's great. Any other questions? No? Let's thank the speakers for this fantastic session. I think it really shows the future of what metabolomics is going to be.